top influential event series in the global metaverse industry. We also established the IEEE Metaverse Standards Committee, which is the first standards committee on metaverse in major global international standards organizations. So I wish the IEEE Metaverse Congress series a great success, and I hope that you learn and are inspired from the presentations and discussions during this Congress. I look forward to working with all of you to create a promising future for the metaverse industry and economy while enabling technology to benefit humanity. Thank you.
Thank you so much, Tom. So next, let me give you a year-end presentation, year-end wrap-up regarding some of our IEEE's activities in Metaverse and also some of my personal opinions. So that's why I have to show this disclaimer. But let's talk about Metaverse. Recently, I have been working on, trying to summarize the history since computer was invented decades ago. So in my view, I would like to divide the history into 5 different phases, 5 different phases of digital transformation. The first phase is, we call that digitalization 1.0, which is actually automation. So you probably heard of I still remember the term like office automation, industrial automation, things like that, which were just because of the invention of computer. And then we went into the second phase, which is digitalization 2.0, interconnection, I call that, which was in conjunction with the rise of internet. I put PC internet and mobile internet together because I think the difference between these two are not that revolutionary. So it's basically about interconnection among everything. And next, we went into the so-called digitalization 3.0, which actually was in conjunction with Web 2.0. So this is a sort of controversial. So recently, many people are claiming that, well, there's a history from Web 1 to Web 2 to Web 3, and Web 1 was read-only, and Web 2 was read and write, and Web 3 was read and write and own. So in my opinion, that is not the real history. That history was invented. It's a fake history. Because if you can still remember the actual differences between Web 2.0 and the web before that, was that Web 2.0 was actually about massive UGC, so user-generated content. But before that, the web or the internet has been allowing read and write from the very beginning. We have like BBS, we have MUD, and other applications. But massive UGC cannot work alone, because if we still have the what we had in the Web 1.0 phase, lots of content generated by users could not be consumed. They would not have chance to be displayed on the front page. That's why massive UGC has to be working together with personalized recommendations. That's why I call this phase digitalization 3.0 personalization. And then we went into the next phase, digitalization 4.0, which was in conjunction with the so-called industry 4.0, whatever. So the core idea, the core concept was that along with the rise of AI, so we see lots more and more intelligence applications in enterprise applications and consumer applications and so on. So I call this phase intelligentization. And the next is what we are facing now. I call that realization. In other words, metaverse. So thanks to the accumulation of all the digital technologies our human beings invented during the past decades, for the first time, we have the possibility, we have the chance, we have the capability to create a new realities, or new universes, although they are in digital format. So that's why this phase is the so-called metaverse or digitization. And I call that digitalization 5.0. With that being said, recently, Steve Ma and me and a few other thought leaders, we also coined another term. We call that XV, Extended Meta Universe. We will be addressing that at a panel later today. But let me briefly describe this. So we are trying to find a term to find a concept to describe the generally agreed scope of a metaverse, but we also want to extend the impacts and emphasize the implications on our consciousness and humanity. So we ended up with the XV, Extended Meta Universe, which combines XR, which is extended reality, and XI, extended intelligence, and XB, extended being, including digital twin, and XE, extended economy, and XS, extended society into a vision that covers not only metaverse, but trying to make some extensions, especially to cover the impacts and the implications on our consciousness and humanity. So with that being said, I'd like to show you the metaverse technology landscape in my humble opinion. So there are supporting technologies including computation, storage, communications, data, and intelligence. And there are also core technologies in three different categories: senses and actions, which basically covers XR and other kinds of user interfaces. So starting from virtual sensors, actuators, and real sensors and actuators, we will have brain-machine interface, body-machine interface, programming interface to support human or creatures, NPC and AI and machine. And we also have another category, which is, I call that a persistent virtual world or persistent computing, which is about how to create virtual maps, virtual scenes, virtual objects, and virtual characters based on modeling, designing, and digital content creation technologies such as PGC, UGC, AI-aided PGC, and AI-aided UGC, and recently the very popular AIGC, and also digital twin-generated content. Based on different engines, we have physics engines, graphics engines, sound engines, etc. And lastly, there's the third category in the core technologies called digital finance and economy, which basically covers digital assets and virtual assets, but including virtual assets and other intellectual properties. But I'd like to highlight that those kind of digital assets or digital finance and economy, they may or may not have to be operating on top of decentralization, and decentralization itself may or may not be running on blockchain. So those are optional, in my humble opinion. So with that being said, I'd like to point out that today we are facing lots of standardization needs. Why we are discussing standards for now? The reason is that recent years, there's a trend that standards that are more and more taking a leading role in industries, especially before the technologies and the markets are mature. A good example is autonomous driving. So, in the autonomous driving industry, everybody is using the SAE GS1316 standard to describe their projects or standards. The projects or products. Like your company is developing a level 2, level 3 autonomous driving, and his company is working on a level 4, and when we'll have level 5, things like that. So that's a very good example that before technologies become mature enough, standards can help pave the road. Standards can help set the roadmap for the industry to help the industry establish the expectations and also help grow the ecosystem. So with that being said, in my humble opinion, talking about the metaverse, we have different standardization needs. I put them in this diagram. At least there are 5 different categories. At the bottom, that should be terminology, definitions, and taxonomy. Some people may feel that we have been debating on the definition of metaverse for a long time, so probably we should forget about that, but just move forward. But I still think it's necessary to have some basic consensus on terminology, definitions, and especially taxonomy, talking about different categories and levels of metaverse to set up roadmap for the industry. On top of that, there will be 3 different categories of standards we need for metaverse. Of course, the most popular one would be technologies. We should use standards to address interoperability, interfaces, formats, functions, performance, safety, security, identity, and privacy, and so on. But in addition to that, there are another 2 very important categories. One is content. So, because of I would say the metaverse or immersive technologies or applications, they are so powerful to be able to influence your consciousness and the body compared to the traditional 2D format content. So we do need to have some regulations or standards for the content, such as content descriptors, such as the content ratings. Like if you have some problem with hate, if you are not aware of what's in the content and you put on the headset and the experience would all of a sudden you feel like you're on a roller coaster, that may cause several problem to you. So that's just an example to say why we need content standards. And another category is social implications, including ethics, ESG, and SDG, and so on. And on top of this, course, metaverse is really a super cross-disciplinary topic, which will generate lots of significant impacts in almost all the vertical industries. So we can expect that there are applications in different industries. They also need different standards. So this is my view of the metaverse standardization needs. But I'd like to just summarize that IEEE today, IEEE drives standardization efforts to pave the road to the metaverse, of course, along with other SDOs and organizations. So I'd like to take this chance to wrap up some of our activities about Metaverse in 2022. We initiated the IEEE Metaverse Congress, which is exactly where we are today. So we started this this session series in June. The first session was just from the IEEE Standards Association's Standards Board Forum. We had a pilot session about talk about the metaverse. Then we had a kickoff session addressing demystifying and defining the metaverse in July, and then we have another 4 sessions, including today's session, address different aspects of metaverse. So collectively, before today, we had almost 70,000 audiences. I hope this number is still growing, of course, and this conference series will become more influential in 2023. And also, we established the first standards committee on metaverse in major global and international SDOs. It used to be the IEEE Virtual Reality and Augmented Reality Standards Committee. So we changed the name officially on September 21st to address develop and maintain standards, recommended practices, and guides for metaverse, virtual reality and augmented reality using an open and creative process and to advocate them on a global basis. And we have also started many standards and projects for Metaverse. Here, I only list those standards and projects which are explicitly include the Metaverse in their titles. We have lots of other standards and projects which are not explicitly including Metaverse in their titles, so we are not listing them here, but I just wanted to say that, for example, 802 series, of course, they will play a very important role in Metaverse. So as of today, we have 2048, which is a standard for Metaverse terminology, definitions, and taxonomy. It was approved by SSB on November 10. And also we started 7016, which is a standard for ethically aligned design and the life cycle of Metaverse systems. So you probably heard of the IEEE 7000 series, which are a very famous and well-known series addressing ethically aligned design or ethics in different areas, especially AI. And the 30, well, we have 30, which is addressing ethics for XR, but the 7016 is dedicated for Metaverse. So these two standards, 7016 and 2048, they are supposed to collaborate with each other, while the 2048 will be setting up the ground for discussion, especially the terminology and the definitions for Metaverse, and also taxonomy covers different categories and levels of Metaverse, while the 7016 will address the ethical aspects. And we also have 7016.1, which was recently submitted. It's in the process of being reviewed and approved, which is especially addressing educational metadata in XR and Metaverse. And just last week, we approved another one, which is called 3812.1 General Requirements for Identity Framework for Metaverse. So, you know, identity is a very important aspect in Metaverse, especially how to determine if you are facing a real person, well, a real person's avatar, or like a fake one, such kind of things. So identity is extremely important in, if we want to make Metaverse truly a society or a ecosystem that we can live in and we can rely on. So this standard will be addressing that problem. I'd also like to add that we have IC stand for Industry Connections Activities. So we started 2 industry connections activities. In IEEE, standards are basically standards development, but industry connections activities, those are activities related to standards instead of developing standards themselves. So industry connections activities are sort of like a combination of study group and also a combination of study groups and industry consortiums. So they are supposed to deliver white papers, various events, and also generate new parts, new standardization requests for IEEE to follow up. So we started 2 different industry connections activities. One is so-called Persistent Computing for Metaverse initiative. We approved that on October 12th. This is about how we can, well, what kind of technologies we will need, and in which way to support the persistence of Metaverse. After Metaverse became a buzzword, I have been asking myself, what's the difference between Metaverse and the conventional VR experience? So my answer was that the major difference is persistence. When we are looking at the one-time VR experience, those are the virtual worlds in those one-time VR experience. They will reset every time you log in. But if the virtual worlds are like that, so any traces you leave in that virtual world or any objects you created in that virtual world will not be lasting. Hence, there will be no meaningful transactions or whatever follow-up actions you can do on top of them. So that's why persistence is extremely important for Metaverse. Especially we call Metaverse, it's named after the universe. It has to be persistent. So, but in order to make a virtual world persistent, we need to have different, have some technical considerations from the infrastructure perspective, from the infrastructure perspective and operation perspective, and also how to upgrade them while maintaining the persistence. So that's why we started this initiative as a platform to discuss, to have such kind of discussions on how to support, build and support persistent virtual world with our current and future digital technologies. We also started the decentralized Metaverse initiative. That does not mean that we think Metaverse should be decentralized. I think that's an optional thing. So, in the global Metaverse community, there are actually two major different views. One view is like Metaverse is basically about 3D, about immersive, about virtual worlds, and they do not have to be decentralized. But another view is sort of like Metaverse has to be built upon blockchain, support decentralized, based on decentralized infrastructure, and support decentralized behaviors like decentralized operations. So I myself kind of more in favor of the first view, but I still think decentralization has some value to the Metaverse. So we started the decentralized Metaverse initiative, trying to find some best practices for how to make a Metaverse decentralized, and also how to let the end users benefit from such kind of decentralized nature of Metaverse. And lastly, I recommend you to see also a recent blog article, Why Are Standards Important for the Metaverse? We listed there some of other IEEE standards activities which are also relevant to the Metaverse. So I put the link on the screen. And finally, this concludes my presentation today, and I leave my contact information on my screen. And I forgot to introduce myself. I'm the incoming president of the IEEE Standards Association. So I look forward to work with you to pave the road to the Metaverse. So that brings us to the next speaker. Let me introduce, let me take a look. Do we have, let me see if, so our next speaker is supposed to be Hugo Swart, who is the VP and the General Manager of XR and the Metaverse at Qualcomm. Let me see if he's in the attendees, need to be bring to the panelists. Give me 1 second. This happens all the time because there might be some technical difficulties. I didn't see any. Jane, did you see Hugo in the attendees? Well, while we are waiting for Hugo, if I see lots of comments in the chat window. So I'd like to highlight that today is an interactive section. All the attendees, you have a chance to interlock with our panelists and the speakers. Please leverage the chat window to submit your questions, and I hope our speakers and the panelists will address that. I welcome Hugo. So the floor is yours. Would you like to share share your screen? We can see you now. If you want to share screen, go ahead.
So they can see you. So they can see it's okay.
They can hear?
Yes, we can hear you. We can hear you. Feel free to start when you are ready.
Can you hear me?
Yes, go ahead. We can hear you. You can just start.
Hello?
Yes, Hugo, we can hear you.
Okay, I can hear you now.
Okay, great. Sorry about the connectivity issue, so you can, the floor is yours.
Yeah, okay, thank you. And it's great to be here. I really respect and appreciate, the IEEE and the whole community around IEEE. So very nice to be here. So let me share my slides, and I hope that everyone can see them. Let me know. Yes. Okay. All right. Let's get things started. So once again, thanks for the invitation. Really, happy to collaborate with the IEEE and everyone around IEEE. So what I'm going to talk about is the broader vision towards the metaverse, and in particular, talking about augmented reality, next generation platforms and processors, along with solutions for head-worn AR. I am Hugo. I lead our XR business, XR Metaverse business here at Qualcomm, and have been working on it for over 7 years or so. So just to set the stage and as an intro, we see big developments, big shifts, technology transformational shifts. First, in the way we compute. If we look at today, most of our, if not all of our interaction with compute is through 2D screens, right? Be it your laptop, your smartphone, or even TVs and cars, and everything digital is essentially through a 2D screen. And we are seeing a transformation of that by not only moving the content, the applications, the services to 3D, but in space. They're computing in space, overlaid on the real world, and that's what many call spatial computing, the spatial internet. And alongside with that, we see big trends around these three main areas, on the connectivity side, 5G and its evolution, AI, together with things like VR and AR. So the move towards 3D computing, spatial computing, along with 5G, AI, and XR is going to be transformative, and key concepts, key trends related to the metaverse. Now, just a little bit of background around Qualcomm and what we have been doing. We actually, started investing in R&D around the virtual reality, augmented reality, a long time back, actually over a decade. Many of you may remember the first days with the Vuforia, where we had augmented reality experience using smartphones, and we haven't stopped, right? We created chips, processors, platforms for VR and AR. We made acquisitions, many of them in Europe. I have a few logos there, and work with the various partners and even doing internal products to really incubate, to really kind of be a catalyst for VR and AR and the broader metaverse. And, we continue to invest. A few pictures here of devices recently launched with our chips. There's also something now called Snapdragon Spaces that we announced. I'm going to talk more about it. And we're going to continue on the journey. We know it's not a one-day transition. It's, multiple years of transformation, very similar to what we saw back when we moved from internet to mobile internet. Now, as we move from mobile internet to spatial internet, it's a transformation, it's a journey, and we're investing in the long run for that. So, one thing I want to say still about Qualcomm is, just giving the audience here perspective of the areas that we are enabling for the XR industry. Of course, Qualcomm for our processors, for our chips, and as I mentioned, we have a full product portfolio of processors for VR and AR. Couple of weeks ago, or actually, it's almost a month already, we announced our AR2 platform for augmented reality that complements our XR2 and XR1 platforms that we had launched in the past. So that's one of the pillars. The second one is really working on software and algorithms. So encourage everyone here in the IEEE community to spend time on these, what we call perception technologies. A lot of it is AI and computer vision, like positional tracking, image and object recognition and tracking, hand tracking, eye tracking, scene understanding, and so forth. So we at Qualcomm are investing on this. We have R&D, we have big teams on it, and still growing. Then the third pillar is building reference designs or kind of reference products that, of course, we don't sell these to consumers, but we use them as a blueprint for customers that want to get a head start from our technology, and then build their own ID, their own products on it. So then the fourth pillar is how do we expose this technology to software developers, content developers, application developers, and that's Snapdragon Spaces. So these are the four pillars that, again, we are investing. We're enabling the industry. If you look at Qualcomm, historically, we are essentially an ecosystem enabler, right? We have the foundational technology, the foundational products, where people, the industry, build on top. So, today, as I said, I want to focus on augmented reality. And in augmented reality, we see four tracks of development today, right? So one is you take a VR headset, and with something called video pass-through, essentially using cameras on the VR headset, I can now see the real world. And, one can say, well, this is AR. Is AR on a VR headset? So that's one track very promising, a lot of development there. And then you have an AR standalone device. You're going to see it's typically a little bit bigger type headset and focused mostly on enterprise applications. Then if you go to the bottom, you have smart glasses that are not yet AR. They're essentially, they have some technology on a head-worn, glass, but they're going to continue to evolve and get better. And then there's something called an AR viewer, which kind of is in between, an AR standalone and a smart glass, in the sense it provides rich experiences like a standalone, but approximate the size of the smart glass. And that's kind of what I want to talk a little bit deeper today, because, when we think about, enabling the metaverse, folks like Niantic, they call the real world metaverse, right? For the real world metaverse, meaning, mixing and matching digital and physical digital content with the world around us, you need, a pair of glasses, and you need glasses that are fashionable, that are sleek, that people can use for a long time. And the thing is, that's very complex. Not only because of the rendering, the visuals, that you want to provide, but in addition to that, you also need to do all those perception technologies I talked about, head tracking, or position tracking, eye tracking, facial expressions, body tracking, controllers, hand tracking. We group that as user understanding. And then at the same time, environment understanding. If I'm going to put a digital content on top of a table, well, I need to understand there's a table and where the table is and so forth. And you need to accommodate light conditions. And that's, when you add all these things up, it's a lot of processing. It's a lot of processing that you need to do. But you want these glasses to be small. If you want these glasses to be small, well, guess what? They need to consume a very low power, because, the more power, of course, you need more space to dissipate heat. And then, it does not get to the form factor that the users want for this to go mainstream. And one way to resolve that we have been investing quite a bit is, what we call distributed processing. If you want to make rich experience on a small glass, but, you need a lot of horsepower, well, what if we don't have all the horsepower on the glass? We have it on an approximate device like your phone or your glass, and then you split the processing between these two entities. We've done things in the past cabled, right? You have an AR glass, as an example, the Lenovo A3 that can be cabled to a phone or a PC. Now, we see these things going wireless, these glasses, AR glasses being wirelessly connected to a phone or a PC, still splitting the processing between these entities. And now the next step, and what we're working very hard on, is to continue on this trend of making it wireless, but also making it a sleeker form factor, where we also do distributed processing even within the glass. And of course, this is towards the future, where we see it's a dynamic distributed processing. Between what you do, what workloads, what tasks you perform on your headset, your head-worn glass, a proximate device like your phone or your PC, or even a router, or the cloud. And these things dynamically move as I'm moving through my day, and different processing units could become available. That's dynamically changed. And in that regard, we announced to make this, to realize this future, that 23 to 25 time frame. We announced last month our AR2 glass, our AR2 processor for glasses. And it's really, groundbreaking technology, purpose-built for augmented reality and purpose-built for distributed processing. And, we look at it for, the best solution to distribute processing between glasses and a companion processing unit, but also, emphasize size. We want to make it physically small, very low power, under a watt, because, it's very hard to dissipate, let's say, similar to a phone, usually around 5 watts, 4 or 5 watts. Very hard to dissipate that in the head if you want to keep the small form factor. And then performance, of course. You want richer experiences. So, what is the AR2 and what's behind it? What's the technology that we enabled with the AR2? So essentially, the AR2 is comprised of actually 3 chips. We decided to have the flexibility of having processing around the glass, not concentrated in one point of the glass. One of the key advantages, of course, it's a thermal distribution within the glass. And then, of course, the solution is optimized to split processing between what happens in the glass and on a host processing such as a smartphone. So now, we designed the AR processor, to be placed in the arm here of the glass. And if you now look at the breakdown of this chip, one thing that you're going to see is a lot of AI and CV and sensing. One thing that you're not going to see is GPU, right? Because in this split processing architecture, you have things like the heavy rendering and processing done on the companion device, like a phone. So you don't need a GPU on the AR processor. That's a big difference. And at the same time, what we wanted is to have acceleration, harder acceleration for key of the perception features. And let's see if I can run this video. Here is a video we took with the device. On the left is a legacy processor we had, that were being used in AR. On the right, is with AR2. And then you see here in the bottom, the measurements that we collect. Blue is the legacy. You see in blue, you have higher memory usage. You have higher power consumption. You have latency for relocalization. When you don't have enough features, it takes time to relocalize, in this position tracking algorithm. And then you see, all these bubbles that you see here, these are all features that the glass is taking for position, for relocalization. So way more efficient, way more power efficient, and lower latency. So that's kind of the, a few of the things that we have introduced in the AR2. Now, in addition to the processor, we said, hey, we also need a coprocessor and, put on a different place in the glass. And, the idea here is that you do some computer vision and AI, and you have a lot of sensor and camera aggregation. If you only had a single chip, what would happen is the following. You have to route so many wires, across the glass. You have many cameras or sensors, in this glass. It becomes a very complex product. And, here on the hinge of the glass, it becomes very thick because of all the wires that are running. So now once you add this coprocessor, what happens is you can aggregate, these camera feeds. You can do some local processing and then minimize the amount of wires that go through the hinge to the processor. So there's very little space occupied on the front of the glass, and very efficiently delivered through the side of the glass. So now, of course, in addition to the processing on the glass, what I also need to do is how do I connect with the phone or with a PC, and for that we use Wi-Fi 7, right? Wi-Fi 7 providing less than 2 milliseconds of sustained latency between these two devices, very high speed and low power compared to previous generation. So that's kind of the three kind of main processors. And the other thing worth highlighting is that with if you want to make a good AR glass, of course it needs to be small. And small, you get that with the lower power. Of course, I don't need a lot of space for heat dissipation, but also the dimensions of the chip and the PCB. We thought about how to make it as small as possible. So we made it a rectangular processor, and very small that can fit on a stylish glass. Okay, so that's kind of from I wanted to mention what we're doing on the processor side, the platform side to enable, this next generation of AR glasses to fuel the metaverse. Now I'm going to talk about how do we enable the technology that we built to developers. You have all these cool perception features that need to be integrated into the applications. And the applications, you still want to be using Unity and Epic, but you want to leverage OpenXR type of APIs, and that we bundled on what we call the Snapdragon Spaces. You can think about it as almost a plug-in to Unity or Unreal engines that provide those capabilities, and you can insert those into games and apps. It's a cross-device, open AR ecosystem. We're already working with multiple brands and companies to enable, this platform, and then working as well with multiple developers, to integrate their existing solutions with Spaces. So then, that's why we say, hey, the Qualcomm, we are the ticket to the metaverse in the sense that we are providing these foundational technologies, be it on the processor side, be it on these algorithms, expose it through Spaces, and then providing that to people, building hardware and devices, people building content, and enabling, the metaverse to flourish. And as I said, really respect IEEE and the whole community around it. We want to get closer. I just put a few references here. If you want to get a little bit more information on what we're doing, very good webinar with one of my friends in the 5G side. How do you do 5G? How does 5G come into the metaverse? You're going to find things around our developer portal, details on, much deeper than what I shared here on AR2, and, a YouTube series that I have interviewing people. So that's kind of, what I had prepared. Thanks again, Yuan, for inviting Qualcomm to this event. And, do we have room for Q&A, or is that it?
Thank you so much, Hugo. I think in the interest of time, so we need to go ahead. But if you can stay with us for a couple of minutes, there are some questions in the chat window you may want to address.
Sounds good. Thank you. Thank you, everyone.
Thank you. Okay, so our next speaker is Sebastian Bourget, who is COO and the co-founder of the Sandbox. So do we have Sebastian. I'm not sure if it looks like we need to address some technical issues. Well, while we are waiting for Sebastian, he will be giving us a talk about how the sandbox is contributing to building the metaverse, especially the open metaverse. I don't see some connectivity issue raised by Sebastian, assuming he's with us in the participants. We have AB on as one of the panelists. I don't know if. Give me 1 second. I'm trying to address that. So, Mr. Boggett, are you with us? Please turn on your camera if you are with us. In that other case, maybe we can slightly change the order. I say Mark Petit is with us. So Mark is a VP of Unreal Engine ecosystem of Epic Games. So Mark, could you do your presentation first?
Absolutely.
Okay, that will be very helpful. Thank you so much. So the floor is yours.
Okay, thank you. All right, everybody. I know Sebastien is very busy, so I just texted him, and we'll see if he can make it. So welcome. I'm Mark from Epic, and it was good to hear from Hugo. Epic is a close partner of Qualcomm, and it was a great presentation. So today we're going to talk about more about real-time 3D. As you know, a simple definition of the metaverse is the internet embracing that new medium, real-time 3D. And until recently, real-time 3D was the hallmark of the video game industry. But over the past 5 or 6 years, we have seen most, if not all, the creative industries actually embrace real-time 3D. And now what's interesting is we are seeing the emergence of platforms that can publish and share that real-time 3D content with very, very large audiences. And those platforms, some of them come out of video games like Fortnite, Roblox, Minecraft, PUBG, the Sandbox. And some other come from social media companies like Horizon World from Meta. And we're seeing a vast number of web-based platforms geared towards multi-user experience as well. So it's coming from all over the place. And I want to give credit where credit is due. A lot of it started with Second Life in 2003 with the work of Philip Rosedale. And I think it's interesting to see 20 years later how we have that perceived acceleration of real-time 3D. So what I'm going to talk about today is when all the creatives converge on a similar technology, and when at the same time platforms are being available to share that 3D content with the masses, what will happen? And I'm going to try to talk about this in the next 20 minutes. So first of all, I want to introduce myself and my company. We're Epic Games. We are known for our games such as Fortnite, of course, Rocket League, and Fall Guys. But we're more than just an entertainment company. We are an entertainment company, but we develop and share our technology, and we've built around the Unreal Engine an entire ecosystem of tools that aims at democratizing, simplifying the creation of real-time 3D content. So we have cutting-edge technology. You mentioned the Unreal Engine, the MetaHuman Creator. If you haven't tried it. Even you, anybody, can use a web browser and create a highly plausible and realistic virtual human. And then we have our distribution platform. We're turning Fortnite into a distribution platform. I'll come back to that. And then we have the Epic Game Store. That is also a distribution platform. So if you want some numbers, the overall Epic ecosystem is more than 600 million accounts. And that represents 5 billion friends connection around our games and around the store. And clearly stated, our goal is to build the open metaverse. Tim Sweeney mentioned it. Tim was talking about the metaverse before it was cool. I would send you back to his SIGGRAPH keynote on the metaverse in 2019. It's on SoundCloud. It's a good use of 40 minutes of someone's time because I think it's, his presentation from 2019 stands the test of time, and I think is still very relevant today. But that's the goal of Epic, how build the open metaverse. And why? Because it will be a huge impact on our life, and it's a huge business opportunity for all of us. I mean, for us, the metaverse is more than just a trend. It's a massive business opportunity for everyone. This is why we're investing so much of our own time, our money, and resources into building both our ecosystem and our own experiences. And we see this as a flywheel that will benefit creators, players, and brands at the same time. The faster real-time 3D gets adopted, the quicker the metaverse will be built by creators everywhere and for creators, and they will result in rapid expansion of exciting and diverse experiences. More players, more exposure for brands, more money for creators. It's going to be a fabulous virtual circle fueling itself and growing, if we do it right. I'm going to come back on that. So usually one thing I want to make sure is that people think about it because, a year ago, everybody was drunk on the metaverse Kool-Aid. It was a very fashionable topic. Now, the vibe around the metaverse may not be as positive now as it was a year ago, but I think a lot of companies are actually heads down and building it. And every one of us, especially in multiple industries, should start thinking, how do we tap into that opportunity and what is our metaverse strategy? And I think it's a very important moment for everybody to discuss. So the thing for me, and love the Snapdragon presentation, XR is an absolute component of the strategy. It's going to be very important for us to consume real-time 3D content that we can have AR and VR. Same, when we hear from Sebastien about the sandbox, the Web3 technologies, the blockchain, it's abstracting, ownership of things from platform, very important topic. But for me, at the heart of the metaverse is real-time 3D. And it's a technology, again, that was born in video games that being heavily and rapidly commoditized by a number of companies, including Epic Games, is being very, very rapidly adopted. This is the root of the metaverse, the internet embracing real-time 3D. Why? Because 3D is interactive, 3D is participative, and 3D is social. But before we get into that dimension of 3D, the important thing to notice is that real-time 3D is actually the most efficient way today to create traditional linear content. If you are making movies, if you are making television shows, if you are making sports shows, if you are making animated series, if you're doing synthetic photos for marketing, it turns out that today, real-time game engine and game engine technology is the most efficient way to create that content. Why? A few reasons. Number one is, think of it as a pipeline in a box. It may not be the best tools, but a game engine has everything: modeling, animation, rendering, logic, physics, combined into one application. In the case of Unreal Engine, it's very open. You can use the internal tool, but you can connect using open standards such as GLTF, USD, or Alembic to the tools of the trade. We have partnership with all the big tools, like our friends at Autodesk, Side Effects, Adobe, the Foundry, with Nuke, and the Maxon guys. So it's a really, really efficient pipeline. The old movie pipeline relied heavily on orchestrating a lot of tools, the constant data translation. The game engine, makes that process so much more efficient. In terms of visual fidelity, we're not at the movie quality just yet, but look at what 5.1 Unreal Engine 5.1 is doing. Look at The Matrix Awakens. You can see for a lot of products, may not work for Avatar and James Cameron, but for a lot of products, the visual fidelity of real-time rendering is probably very adequate, especially that's real-time is fast. We do things in milliseconds. And in the case of Epic, the tools are very, very inexpensive. So this has driven the adoption of Unreal Engine into many, many industries. And why is because especially in our case, we've invested in a lot of technology to solve some very specific problems. So how do you create complex environment where we have our Megascan library, and you can kit bash new biomes, new virtual worlds very efficiently and very quickly using Megascans. We have our marketplace, we have Sketchfab, 5 million users, millions of 3D models, lots of them are free. You can drag and drop them directly into Unreal Engine. We have our own marketplace, so you don't need to spend a lot of time creating things by yourself. You got all of those libraries you can lean on. I called on MetaHuman already. It's like, it's use AI and game mechanics so that you can create a character interactively in a web browser. It's a cloud application, see what it looks like. It has dynamics, animation, playback. You can say, hey, that's the character I want. It uses machine learning technology to kind of create a ring fence around the uncanny valley, so you cannot create a character is not going to look like a human. And so we have all those tools. We have the Unreal Engine itself, and a lot of online services, so that become very, very easy for many more people than it used to be to create interactive 3D experience and to connect them using online services. We have our own Epic Online Services platform, but we have a lot of partners in that space that provide services. So it's still, 3D is still complex, but I think we're seeing a massive, massive acceleration of things getting easier. I don't want to use the word acceleration too quickly because that's the topic of this slide. I mean, I was fortunate and old enough to see the first generation of computer graphics, the Jurassic Park days where we're going to SIGGRAPH every year. We were blown away by the innovation. I think it's happening every other week, the innovation, and particularly around AI and machine learning. So the first thing is, Moore's law seems to be at play. We get better hardware from our hardware partner. But what's fascinating to observe is that, with machine learning, it actually becomes much faster to guess the neighboring pixel or the neighboring frames than to compute it. So the machine learning, like technology like AI denoising, or, credit to credit is due, NVIDIA's DLSS technology, which guesses entire frames and accelerate games by a factor of 4 or 5x. These are fantastic technologies that are being democratized. And so not only we have the natural hardware acceleration, but we have that machine learning acceleration. I mentioned, AI-assisted artistry, the MetaHuman creator is a great example. We see that everywhere. And I'm not going to get into generative AI. You guys read the news. It's starting to tackle in 3D. So those elements makes me very, very confident that we'll see an even, faster democratization of real-time 3D. So something that was barely could barely think of a few years ago, many people will be able to create interactive experience in the virtual world. So we need to be ready for that. And so that allows me to say the real-time 3D revolution is happening now. Real-time 3D as a medium, I predict, will become as prevalent, if not more prevalent, than digital video. Why? Because it's social at the core. And when you do something in real-time 3D, you can do it with your friends, with your colleagues, with your family. And the next generation, they will not accept a form of media that is not interactive and is not social. So I think it's happening. We already have 650 million people on very generic games platform. It's happening. And it's happening right now driven by social gaming, but it's not going to be just for social gamers. So where are we with adoption? So in games, of course, we're seeing a lot of companies move off from, what used to be the hallmark of custom game engines now can be done with commercial engines. So we got a lot of commercial game engines in games, of course. Virtual production, you've seen The Mandalorian. If you look at Netflix shows like 1899, you may not realize, but it's a lot of in-camera visual effects, not real-time 3D being brought to those LED screen on stage, completely revolutionize the film pipeline and make it much more efficient. Animation pipeline is the same. We're seeing a lot of Netflix TV series and for other platforms being built with Unreal Engine at the core because the pipeline becomes more interactive, more iterative, and allows director to get much quicker to their creative vision. But it's also an architecture. Architects are building digital twins of buildings and entire cities using real-time 3D everywhere. Automotive, of course, we do the marketing, car configurators, car commercials, but we are in the car now. Game engine technology is, especially the Unreal Engine, is the right language and it's the right user interface to interface with the complex machine that a car is. So we run the dashboard of many cars. You see the Rivian here, the Ford Mustang, the Cadillac Lyriq. It's very interesting to see that technology being dispersed. Fashion is interesting because if there is one place when we do not have digital twins yet, it's actually garment and clothing. We can't model interaction of properly in real time of a jacket over a shirt. Every piece of clothing in Metaverse right now looks like skins, but that's an area where a lot of people are working. And even though it's not at the level of visual fidelity that we want it to be, we're seeing massive adoption of real-time 3D for product visualization and in the fashion and the e-commerce industry. Music is the same, embracing real-time 3D very, very fast. We see a number of initiatives. We bring the real-time 3D on the concert stage, but we also create an online learning platform. So as you see, all of those industries, as I said, the thesis is that all of those creative industries are converging on the same set of tools, and these are, those game engine technology and primarily the Unreal Engine. So we have fantastic technology, we have great usage, and now what's happening, is that in 2022, and we have platforms to enable the consumption of real-time 3D. 3D is always difficult to consume. The entire game industry was based on, very, very specific hardware, but now we're, with web browsers being there, with pixel streaming from the cloud, and with the generation of those game engines, it's very, very easy to create a platform to consume real-time 3D content. And those platforms, again, by nature, they are social, they're interactive, they're participative, and they provide co-experience. And hopefully, I'm a big believer that VR and the killer app for VR will be co-presence. I will accept to wear a VR headset when it provides me with the capabilities to feel that I'm with the person that I'm with. So I think co-presence is not there today. There's embryos of it, but I'm a strong believer that, as I said, we can reach a moment where co-presence is actually working and we can be with people we like and do something together. And that's the heart of the opportunity for the metaverse. But building those platforms, it's complex. You need a lot of components. You need creation tools, you need that social layer, that social graph, you need that interactivity engine, but you also need discovery, commerce, persistence. It's a difficult, it's a difficult endeavor. And the goal is, again, to create interactive 3D and connected experiences and make this available to everybody and make this at the level of quality like you can see here. We believe that, that Matrix Awakened content is a good benchmark of what we want the metaverse to be looking like. And we also believe and propose that Fortnite is a very early version of the metaverse. It's a place where you can already experiment. You can play a game like the Battle Royale game, but you can also come and experience concerts. We do Short Night, which is our animation festival, and a number of other activities. And we're building it for tomorrow. We're making sure that that we are community first. You may or may not know that as of today, more than half of the hours played on Fortnite are played on experience not built by Epic. More than half of the hours are played in games created by people in Fortnite Creative or Island created for all kind of purposes that some of them are listed on that slide. Fortnite is just more than that Battle Royale game. And of course, we have a commitment to connect the Unreal Engine so that you can one-click publish from Unreal Engine to Fortnite Creative so that everybody that understands the Unreal Engine can have access to our platform. What are people going to do? We don't quite know because, it's the early days, but like this concept of playable TV shows, we haven't quite seen the merging of linear storytelling and game mechanics. And we expect to be amazed and see a lot of innovation when on platforms like Fortnite Creative, but also on Roblox and on Minecraft and on all of those platforms on the sandbox, people can actually have the right set of tools to create those new genres of experiences. So we are looking forward to be amazed. We're also looking forward to give brands and people doing business better tools to engage with their audiences, like digital showrooms, simulation, and so on and so forth. So that's what we're doing with Fortnite, and that's what we see happening, building on top of game engine technology. But what matters to us is that does not, we want to learn a lot from the lessons of the past 15 years on the current generation of internet-based platform. And we have very, very public aspirations, and we have very, very public fights as well, so that the metaverse ends up being open, fair, safe, and of course, it's social at the core. So it's very important to us. As we say, we have some very public fight. I'm not going to talk about it today. What I'm going to talk about today is all of our investment and our support for open standards. It's very important that we come together and create those open standards for real-time 3D content. When I said all the creators use the tools, and we start to have asset reuse, an asset that's creating for a movie now can be used in a game, can be used in the marketing experience. We'd like those assets to be expressed in open standards format. We look at the current platform like Fortnite and Roblox as being a little bit like the internet was at the days of AOL and Prodigy. It's not yet the open internet. It's more like platforms that needs to be connected, and the connective tissue we believe should be open standards. And we have a big investment in making this happen. I want to call out, my friend Patrick Cozzi and I organized a class to SIGGRAPH back in Vancouver this summer about having a lot of industry leaders come and talk about how we can build the open metaverse together. Something's very important. Patrick and I also have this podcast, a shameless plug for our podcast, but we have 40 episodes of interviewing some of the industry leaders and make the case and start to get ideas on how we create that open metaverse. That's very important to all of us. And finally, on one of the podcast episodes, Patrick and I were talking to Neil Trivet and realized that it dawned upon us that the metaverse it's virtual simulated world. I mean, the metaverse will be all-encompassing. It will provoke the collisions of a lot of disciplines that are not talking to each other right now. 3D, of course, but also video streaming and spatial audio. And then those platforms will have to have identity, will have to have, a lot of new business model and, et cetera, et cetera. And one thing we realized is, we didn't have a venue to host that conversation, and tell people, hey, the metaverse is coming. We need to start to talk to each other. We need to understand what each other is doing. So that's why we started on this idea of the Metaverse Standard Forum to just, host that conversation and drive the cooperation. And in June 22, we talked to a bunch of organizations, and it's resounding with a lot of people. We got 37 founding members. And now, as you know, we have a lot more. I think in November, we're past 2,000 and 2,200, which I think we hit a nerve in terms of, the need to communicate and to collaborate, and people understanding that no one company will build a metaverse on their own. Well, maybe one company thinks that, but the rest of the world doesn't think that. And collaboration is going to be absolutely required and mandated. And we need to discover, we need to know who is doing what and doing those things. And that's really the purpose of the Metaverse Standard Forum, of which IEEE is a partner. And for example, one thing that there's a number of conversations happening on digital avatars. I encourage you to go to the website forum. One thing that Patrick and I and a few other people are really involved with is 3D asset interoperability. Start with the core mechanics, the core plumbing, making sure that we achieve that vision, that you can author interactive experience and publish it on all the platforms so that creators don't have to bother with the drudgery of a lot of that interactive content development. So good example, so, in our industries, we have great authoring solution using like USD and Material X, open source project. We have a very, very wide adopted, transmission format called GLTF, and we realize, people are implementing concept in those things that do not guarantee lossless interoperability. So let's get the thing together. So that's something that's happening right now. We have created a domain working group on 3D asset interoperability. And then we are hosting that conversation between all the parties, in this case, open source projects like USD Material X and other standards to make sure that, hey, the way we describe materials, the mass is the same, so that we're enabling the basic level of interoperability and making sure that we achieve that vision that you can author once an interactive experience and duplicate it everywhere. So we didn't want to create a place to talk the talk, so we're also trying to create projects that are going to be very, very pragmatically implement and demonstrate that the concept that we are supporting will work. And again, we're not a standard defining organization. We have a lot of SDOs. We're actually having a very interesting project, which is a registry of all standards. And believe me, that's Christine Perez doing this work with a lot of other people. It's amazing number of standards that we have. And, so we're going to do that register, and then we're going to try to do, again, host this conversation. In case of interactive content, not only you need authoring interoperability so that, a creator can use the tool that they want. I want to use Maya, somebody else wants to use Houdini, somebody wants to use Unity, somebody else wants to use Unreal. Why don't you use all of those tools? I mean, in 2022, where, collaborative authoring is becoming a thing. So we want to create a specification so that, not the specification, but the requirements so that we can have, solutions that allow collaborative authoring, multi-tool workflows. And the other thing that's very important for us is, like, if I create a car configurator, I'd like to create it once and use the tools that I want, but then I'd like to publish it to as many platforms as I can. I don't want to author for Roblox, or I want to author for Fortnite. In a perfect world, I'd author, and then I'll be able to publish to Fortnite, to Fortnite, to Roblox, or to Unity. And so all of that technology and principles, so that you can kind of transform a generic representation interactive experience into something that's optimal for each platform, like the sandbox uses voxels, or all of that is actually the nature of the conversation. So it's a very, very ambitious endeavor. It's a long and complex conversation, but so far we are doing pretty well and pretty happy with the result. We got the key companies engaged, and we have some very, very pragmatic goals to create a foundation. So I would say that from my perspective, the collaboration amongst industries is the all-time high, especially a year after, where we are. The economy is not what it was a year ago, and I think everybody is much more humble about their contribution, is probably understand, the solution is through collaboration. And so I'm naturally an optimist, but I'm still very optimistic about our ability to create those standards, and for the Metaverse Standard Forum to come up with those requirements so that the right SDO can pick up those requirements and do their magic with their, and create the standards that we need for the open Metaverse. A little bit of an update. So we're still at the early days of that effort, agreeing on the principles, but things are happening. And so if Web3, I want to leave you with a thought, because if Web3 is associated to blockchain and all of those things, I think we should already talk about Web4. And, remember that, we come from a world when things were open. We had macOS and Windows, Win32. We can say a lot about those companies, but they were open platforms. We moved to iOS and Android and not open platforms. How do we go back to open platforms is something that a topic we're very interested in. The other thing is the gap that there is between, browser-based experiences and native experiences is still very big. Some of it is explained by technology, but some of it seems also be driven by the interest of the platform owner to drive people to native and to their store. So when it comes to 3 in the Metaverse, we believe that the web browser is a very important aspect. If we want a nice creator and user experience, we need to go to browse from Fortnite to Roblox seamlessly. I mean, we cannot stay with the Roblox.exe and the Fortnite.exe. So I think we all learn, and some of us think that what we currently see on the web is not what the original vision of the web. So I'm really hopeful that the migration to real-time 3D, that sea change in core technology, that new medium that real-time 3D is, will drive us to think differently about the web and drive us towards a vision of the web that is what we wanted the web to be, which is open and participative. So should that be called Web 4? I don't know. I'm lost in the numbers, but I do think that as an industry, as a standards, people thinking about standards, we need to think about the next step for the internet and and think very, very hard about new browsing paradigms. That's going to be my closing comment. I thank you, IEEE, for inviting me. It's a great opportunity to talk to you all. And I will hand it back to you, Jan, to see if there are questions or how we want to handle the next steps.
Thank you so much, Mark. Lots of information. I'd like to add that thank you for mentioning Metaverse Standards Forum. IEEE is a partner SDO of the Metaverse Standards Forum, one of the 19 partner SDOs of Metaverse Standards Forum, along with other SDOs such as W3C, Web3D Consortium, OGC, and Kernels, of course, and many others. Also, thank you for bringing up the concept of Web 4. It's very important, very interesting. So, in the interest of time, so let's welcome the next speaker, Sebastian Bourget, the CEO and the co-founder of Sandbox. So, Sebastian, could you turn on your video?
Hello. Hi, everyone.
Yes, the floor is yours. So you can share your slides if you like.
All right. Right. Ooh. Okay, I have to restart the first time I open this up. Sorry.
Well, technical issues happens all the time, but anyhow, so while we're waiting for Sebastian to restart, I think maybe we can take some questions for Mark. Let me see if there's some questions in the chat window. But basically, I think I like your concept of Web 4, but my humble opinion is that I think if we are talking about the next generation of internet, probably we should call that internet for something like that instead of Web 4. Because Web is, to me, it's like technically Web is sort of within a narrow scope. What do you think? Like in the Web 2.0 age, because everybody is using Web to browse the internet. But after that, we are more relying on apps. So I think when we are talking about the next generation internet, just from the terminology perspective, we see some other people coined the term Web 5, Web 6, and several others. But to me, I would prefer using internet instead of web. Just my problem.
I think what's important to me is that to understand that it's early days and we should not get ahead of ourselves and maybe maybe some investors and the pandemic got us to get ahead of ourselves, but the real foundation is that new form of media, real-time 3D, and we need to commoditize it. I mean, the Web 2 was built on the commoditization of digital video when everybody could film videos with their phones. So we have to work towards the equivalent of that for real-time 3D, and that includes, those open standards. And I saw somebody, mention USD. I think it's a very interesting, foundation to create what the HTML did, for text, for hypertext, to create something on the foundation of USD for virtual worlds. So, but I think we need to pace ourselves. On one hand, it's happening in the social gaming environment, but on the other hand, we don't quite have all the pieces of the puzzle for mass adoption of that technology.
Thank you. Okay, I see Sebastian is back. So, Sebastian, could you share your screen?
I really apologize. The first time I use this software, it keeps asking me permission all the way on my computer, and now it doesn't want to screen share. It's trying to
It's working
upload
now.
the file instead of.
It's
Is
working
it
now.
working?
Yes, yes.
All
go
right.
ahead.
Thanks for your patience then. Okay, it seems to be loading something. All right, great. So thank you so much, and I'm glad to come right after Mark has presented. So I think like that's already helped a lot, like for you to get a big picture of what the metaverse. At Sandbox, we are one of those open, decentralized virtual world, trying to also like contribute building the open metaverse. Okay, video are not playing. All right. So let me share with you a little bit like how we see the metaverse. We really see it as this myriad of virtual world where anyone can start like accessing more social, more fun, more immersive, more creative experiences through an avatar. So that avatar becomes our new digital identity, and we can like use that avatar across any of those virtual worlds. So unlike what we've seen before into video games or MMORPG for over 30 years, like we're no longer constrained in one single platform where to continue as part of this bigger creator economy or even as players from their activity. We believe that such like metaverse needs to be built on a technology that is right from the beginning like fully transparent, trustful, that ensure the proof of ownership, the proof of authorship, and the proof of digital scarcity. And that technology today is blockchain. Instead of relying on centralized APIs controlled by centralized company, which provide data that are not transparent, we have like this public ledger that no one can hack, no one can edit. It's here, and now that we have digital assets of value that are stored on that blockchain and that users own, including their identity, their avatar, and more, we could establish a whole new layer of an open economy that will give birth to new jobs, services, and jobs, even leading to decentralized finance and ultimately to decentralized governance, where the stakeholders of those platforms who own those assets can also participate into the governance and even like develop the future democracies of the virtual world as citizens of the digital world. So I'm really sorry, but videos are not playing, it seems. So we're going to miss a lot of key information on my slides. Normally, we have 400 brands that are already part of Sandbox. We really are building this platform as a new global digital nation where our users and avatars are with their avatar, like they are the citizen of that new world. But we're also very attached to make it concrete for like anywhere you are in the world. Yes, there's something that appeals to you that makes you want to come and play and interact into it. And that something is like local brands from different regions, like in Turkey, in Dubai, in Korea, in Hong Kong, in Japan. There are local brands that people are more familiar with. They will enter because they are fan of like the artist or content they are familiar with, but they will stay and discover the rest of the content on the platform. And those contents that you cannot see include like gaming studios from Ubisoft, Atari, Square Enix, music label like Warner Music or SM Entertainment, largest K-pop label in Korea, even media, South China Morning Post, Kalish Time, magazine like Time Magazine are present in Sandbox. You will find music artists, of course, Snoop Dogg, Steve Aoki, Blondish on one side, but you also find Asian artists, Hanjin, Nine Chen. You also find brand in entertainment, Care Bears, Smurf, Pororo, alongside Walking Dead. That's a very exciting world that mix a lot of great content. What makes also the metaverse unique, it's based upon virtual world, and the way to navigate and enter the virtual world is essentially through a map. So not just a gallery of games that have no correlation one to another, but a map which provide like this spatial access where users with an avatar can walk from one map, one land, which is like this digital space of real estate where the experiences are being published, to another with their avatar, and like the proximity of them, like two parcels of land being neighbors, like you explore with your avatar and you move from one land to its neighbor land. That allows also to develop new communities of neighborhoods where like you can create and co-create with your neighbors exciting experiences. And people love to be the neighbor in virtual world of their favorite brand and celebrities or artists. Like who doesn't want to be the neighbor of Time Magazine or Snoop Dogg or Tony Hawk and so on. So far, our map in Sandbox has a finite size, 166, 464 land. There will be never ever anymore. That's ensured by blockchain. But the metaverse itself could be this infinite number of virtual worlds with finite or infinite number of land. We are acting like curator and selecting, crafting those neighborhoods by thematic, by region of the world, so that it's always a boiling place, vibrant place, active 24/7, where people will enjoy coming with avatar, having fun, socializing, and more. Once again, sorry, the slides are not showing properly. I had nice videos, but what can you do in a land? You can already like socialize with other users in Social Hub. You can like dance with your avatar through body animation, emotes, and we know how much like avatar animation are successful. Fortnite has shown us the way, and it's a large part of their monetization model. People enjoy listening music and expressing with their body together. They want to access like virtual shows, virtual concert. They want to build the place, the home for their virtual avatars, and also why not decorate their house. They want to be amazed and discover new places from the virtual world. And like we're proud to have like already countries, board of tourism from various countries, and Indonesia has been the first one introducing Bali in the sandbox. We have Shibuya 109 in Japan, and other key locations you can already visit. You can also visit art galleries, museums, as well as fashion, discover fashion, work together, learn, and of course play games. We had some metrics. I think like even we're still very early on in the metaverse. Sandbox has a growing audience, has a growing community, a growing ecosystem. And I wanted to share some of the metrics from the last Alpha Season 3, which was running between August and November 2022 for 10 weeks. We had a total of 17 million visits. Users spent 2.4 million hours playing, a total of 360,000 unique players and 30,000 active on a daily basis. So things are starting well, and we're seeing engagement. People are having fun, sharing real emotion, laughters, and more. And like one of very impressive metric I find is like 1 hour 20 average daily playtime per user shows that they're already committed and engaging and chatting, and having a much bigger attention span within those experience that you can find on traditional social media, for instance. Some of the top experiences during that season, including content from brands, but not only. We also saw like Ledger School of Law, which has been like an educative experience about security and learning how to protect yourself against like phishing, scams, and other risk factors that exist in Web3, but also beyond. We believe that Metaverse is really contributing to create like this new digital economy and will lead to the creation of millions of jobs. Jobs that relate to creation. You can be an architect, a house designer, fashion designer, game designer. But not only, like content discovery will play a major role, and people will be tour guides, hosts, welcoming each one of our avatar and giving them like more customized experience. We'll see new businesses appear, people selling virtual real estate, curating fashion, selling tickets for events that they run, and even playing and exploring will become a job in itself, since all the rewards you earn for the first time are token on a blockchain that you can keep, hold, stake, resell as you wish. Our ecosystem is largely growing. This year we moved from 10 studios building in Sandbox to 230 studios at the end of the year. So progressively, we're seeing on every continent of the world people who are making their job, making their life into like creating this experience for the metaverse. And ultimately, like success of virtual world and metaverse itself will come from the success of that ecosystem that's growing, where those creators, those artists, those consultants, those agencies, builders, and more will earn a revenue by selling content and receiving most of the value from the content they created for themselves, so they can reinvest it within this creator economy. Here again, I'm really sorry. This slide is supposed to show the importance of like avatar design as our new digital identity. We don't need to look like the same as the real world in the metaverse. We have the chance to be reborn, and we can pick whether we want to be a man, a woman, a non-gendered person, or even a non-human creature. People that makes the metaverse much more inclusive, because ultimately we don't age, we don't know which are the ethnicity or background from people that we interact with, so we truly interact with them for what they are and what they contribute to toward this new digital world. And each one of those avatars should be an NFT, so your identity is unique. No one can be like you, because there could be only one Snoop Dogg in Gucci in the world. And going even further, if we want to be an open metaverse, we should be a platform that accepts avatars from all other virtual world and platforms. So typically, we already support through interoperability. So users own on their wallet all other digital assets, other NFTs from some of the most popular avatar collections, like the Bored Ape, Moonbirds, Cybercoms, World of Women, Snoop Dogg avatar, and so on. And they can use them in Sandbox, where have the technology that turns those models from 2D images to 3D avatars using GLTF and Vox. They're already animated with 70 plus animation, so they can jump, run, fight, dance, do a lot of cool stuff. And that helps like create this world where like you meet like a great medley of characters from all different horizons. It's quite exciting. We also try to emphasize a lot about the IEEE, that the metaverse is still very early, so we're trying to build the usage patterns. We strongly recommend anyone considering building in a metaverse to focus on creativity first. It's not yet the time to come and try to sell, be very transactional. We have to first bring users and train them and engage them with fun content. And on the opposite, instead of extracting value from users, we want to give value to them, giving them rewards for the time they are going to spend in those immersive experiences, reestablishing a link through Web3 and wallets, a link that we lost with Web2 platform that started to collect data on behalf of those users for retargeting them with ads and cutting brands from the direct access to their own community unless they spend on those advertising platforms. And like we also recommend brands to think like, how do they want to be perceived? What are their core value? How do they reinvent themselves in the metaverse? And they could do so by embracing the culture from that world, collaborating with other projects, displaying content like NFTs from other projects, and also opening themselves to user-generated content, letting the community co-create with them their presence, and hence multiplying through UGC a lot of content and the engagement from those communities of fans. And we've seen great success with various game jams following thematic from some of those popular brands. 1,000 to 10,000 of creators submitted content, progressively learning as well the skills and onboarding to the platform. And once again, I'm deeply sorry. I wanted to show you some concrete example of experiences we already launched. This first one was the Gucci Vault that's open for, it's a digital art space that's been curated by Gucci, and also take the character, the users with the avatar through quests where they learn more about like the Minecraft shift that's been applied by master artisans, make them collect box, complete quest, and earn reward, including both NFTs and physical ones. This one was like the first Halloween event run by Paris Hilton that we created like a very special manner and party for her fan. This one was supposed to be the rabbits invading the metaverse in a very fun way. So not just building, but artificially exploding things, and players have to reconstruct, find the different rabbits scattered around. This one is the music theme park for Warner Music, which like gives you like different music genre to explore with your avatar, and also give you a chance to like discover other artists and get closer to like them. And finally, wanted also to show like Metaverse is not just for like it's already great for gaming, entertainment, music, sport, lifestyle, luxury, fashion, but also like we're seeing banks, financial institutions, insurances, and more traditional businesses also come to the metaverse, but creatively with ways to engage their users, like HSBC launching a sport-related hub, or as an example. And once again, I'm really sorry. I feel like this presentation is just half of what I could deliver with the videos. So if you want to reach me out for more questions, I will tag my address in the chat. And if you're curious still, you can enter the metaverse by joining sandbox.game. It's free. You don't need to buy anything to start creating an avatar and start exploring yourself. Thank you very much.
Thank you so much, Sebastian. That's exactly why we needed the metaverse for, I would say, smoother communications. So for the interest of time, let's switch to our next item on the agenda, which is the panel. The panel will be addressing challenges and risks in evolving 3D standards for the metaverse. We have moderator who is Roland Heinz, who is the co-chair of IIIF 3D Technical Specification Group and a senior computer officer of University of Cambridge. And we have panelists including Vince Machete, co-chair of X3D Graphics Working Group from Web3D Consortium. We have Catherine Das, who is an architect of UK House of Commons, and also representing
now. Oh, sorry. Local glitches are part of the metaverse. Thank you for the kind invitation and introductions. We've all been introduced, and it's thanks for the speakers gone before. We're coming from a slightly different angle, which will be obvious shortly. I put a link in the chat area of slides that will accompany some of our discussion to help illustrate things. And with that in mind, let me share. Oops. Could I be enabled to share a screen? Great, thanks. And let's go to. So hopefully you can see those slides. Great, and if not, let me know. Vince, can you see that okay?
No, not yet. It's still just gray for me, a gray background.
Let me try that again. And at least people can follow along with a local copy. Any better?
Not yet for me. Have you advanced to one of the screen with content? Because again, all I'm seeing is a stippled background.
I'm getting a warning about too many overlapping windows, which is interesting. I'll try one other way. Stop sharing that. So Vince, let me start and I'll get your slides going. Would you get us started with an overview of the development of the X3D format, its history and significance, and its ISO status? And then added to that, could you also say something about the Web3D Consortium's support for GLTF also becoming an ISO standard?
Okay, well, while you're waiting, what Ron is hopefully will show in a moment is a neat slide with a swoop upwards of the evolution of the X3D standard. And we've talked today, the speakers, about looking forward with standards, and it might be useful to look backward in standard. What has turned out to be a long-lived standard. So again, I don't have the slide, but X3D is a standard for 3D visualization, which has a history going back to '95. But perhaps we're like to start at 1997 with Vermal 2. Now, I know many people here, or at least some, perhaps not many, remember VRML. That's virtual reality modeling language. Vermal 2 was the version in 1997, 25 years ago, and again, the slide would explain this, but I'm trying to remember. I believe 2003. It was kind of subsumed or extended, or whatever the word you want to use, into the X3D standard. So one great consequence of that is Vermal 2 content will still render in a modern X3D viewer. So that's a pretty long history of what we might call backwards support, or allowing content to be persistent over a long time. I believe it was about the same. I should say that, again, there's a 25-year history. I have been kind of active with the consortium for about a quarter of that time. So I'm looking back on people who told me the early history. But about that same time, in the early 2000s, it was adopted or ratified, I should say, as an ISO standard. The number is 19775, and it's a multi-part standard, but numbers around 19775 for the ISO number. I would recommend, if people are interested, is if you go to the consortium website, and that would be web3d.org. Unlike many ISO standards, the X3D standards are available for free viewing. So you not only have the advantage of an ISO standard, although you have the option of purchasing the standard documents from ISO for a few hundred Swiss franc, you can view them for free on our website. And although we are a membership organization, those documents are publicly available. I mentioned the 25-year history, and I can zoom forward to about a week ago. On December 1st, ISO announced the results of the latest ballot for X3D version 4, and it was accepted by the various national bodies. So we are still an ISO standard. We have X3D version 4. Oh, I'm seeing it, Ron.
Great.
Jump to slide 4.
Okay. Had to do a lot of acrobatics.
Yeah. So the actual ballot standard, the ballot, those of you who are familiar with ISO, there are many levels of progression in getting a new standard. But the result from December 1st was the last ballot step in publishing it as X3D version 4. And it will either be called 19775. I believe it will be 19775.2023, because I don't think the actual publication will be until early next year. But we're real happy about this, celebrating this 25 years of standardization. Okay, so there you see the document. The point I want to make, which I think is useful going forward for thinking about open standards for the metaverse, is trying to look back and see what is it that made this successful as a long-lived standard. And I would put it this way, that the X3D specification standard, whatever you want to call it, is not tied to a particular technology, to a particular software library, certainly not to a particular application, commercial or otherwise. I mean, very often, what we see nowadays for 3D visualization is very often a particular library in JavaScript, if it's going to be on the web. And they have a published API, and authors can write things to create scenes using that library and viewed in the web. You can have similar libraries on other platforms, the mobile platforms or a desktop platform, but you can call it a standard if you like, but it's really more in the nature of an API. Programmers, authors learn to write to that API.
So
Similarly, yes.
I'm sorry. Finish your thought. I just want to interject in a moment.
Okay. Similarly, there might be a very good or very popular or very capable viewer which publishes an API, and again, authors would construct scenes that write to that API. So now, Ron, you want to?
Yeah. Do you want to say a little bit about how some of these standards formats can work together? So scenes, including X3D, GLTF, etc.
Well, okay. So I'll finish my thought, and one consequence of that is that the X3D standard, the way it's evolved, has jumped through several different kind of platforms. It started out with basically plugins working on the early browsers. Once JavaScript kind of came and took over the world, and things like Flash Player became historical relics. We have viewers that use X3D in web browsers, as well as viewers that use X3D on the desktop platforms. Jumping forward to the recent development, I just included X3D version 4. One thing that we added was support for what is now also an ISO standard, and that is GLTF. And I like to term it GLTF offers digital assets. That is, in some transmittable form, you get a model of some kind. What the X3D writers, what the consortium did is allow, again, version 4 to display those in line in a scene. And in fact, it can be independently retrieved from an external server. So you see that in the 2022 documents that we mentioned, that cooperation, or it's a 5-syllable word, 6 syllables, interoperability, but it simply means an X3D author can bring in those digital assets from this other format, GLTF and GLB. So one capability of the metaverse, as our colleagues have shown us, is I call them mashup. An author is not responsible, or even has no control over all the things in her scene. Things can be added in from other users. That's going to bring its own problems and challenges in sort of the wild, wild west. But we have the technical ability to bring in content from these disparate formats.
So, pardon me, Vince. We're probably going to have to pick up the pace 1 eye on the clock. Do you mind if we go to your next mashup?
Yes.
Example?
So let me, just as a concrete example of that, what I'm doing is, while Ron switches the slides, I am going to put this in the chat to everybody, because this is a live web scene, or a 3D scene available on your own browsers. Ron, it does take a while to load, so that's why I suggest if people want to, they load it on their own machines. But This is a mashup of 3 goblets that are independent models, all available as GLTF assets. Now, in this case, they all came from Sketchfab, but ultimately from 3 different authors. The wooden goblet is from a museum in England. The kind of the colorful one there is, I think, a private viewer scanned something, and the coffee cup is actually, it's a CAD model of a coffee cup, Starbucks cup, but offered on this server as GLTF. What this scene demonstrates is we can bring them all together in an X3D scene. That marble tabletop is itself simply X3D geometry and X3D images to show that kind of marbling on it. And if you do look at it on your browser, the interactivity and the ability to zoom in on different items offered by the HTML, that's all implemented in X3D. And one of the features of it that makes it a useful standard is all those that behavior of how it behaves when you click on something, when you navigate, when you apply lighting. That's all specified in the standard. And so you can have different viewers in different platforms, all implementing it in a consistent way.
Thanks, Vince. We should probably move on. George, any closing thought?
I'm just open for questions.
Great, because that's for everyone's benefit. We're going to try to rush through more of the material and then have a broader discussion and come back to any and all points. Catherine, if we turn to you, I have just a couple of questions. Would you share some of the 3D related information interchange challenges in your work on the Big Ben Tower and the UK Parliament building? And in addition, could you also say a little bit about the developments in HBIM or Heritage BIM or BIM for Heritage, the building information management, and the practical uses, implications for digital twins?
Thanks.
Over to you, Catherine.
Thank you. Can you go on to the next slide, please?
Okay.
So
Building.
this is kind of taking everyone way far back. I know we've been talking about the future. So this is an image of the parliamentary estate in the 1530s. So there's the slides, the link that it gives a bit of background. So I'm just going to kind of jump to the next slide, Ron.
Okay.
So this is what we see on Google today. So Westminster Hall, sadly in 1834, there was a great fire and the area marked up in red is the only area that survived. If any of you have seen the Queen's Line instead, that happened in Westminster Hall. So it's got so much of history and again, challenges as part of the architect working in the organization. Our team's challenges are kind of trying to link and maintain our historic estate, but at the same time preserving it for future generations. So one of our challenges recently using digital construction, which is also known as BIM, was the first attempt on the Big Ben, which is on, actually the name is Elizabeth Tower, known as the Big Ben. So the next slide, please, Ron. So to give you a bit of background to Big Ben, it looks vertical, but in reality, it's not really vertical. So it kind of tilts about 250 millimeters, not as much as the Pisa Tower in Italy, but it does tilt. So the challenge with working on a heritage building is very often most of our historic assets are not vertical or horizontal. In the 3D world, when you do 3D modeling, most of the time the model is extruded. So one of the kind of challenges we had with this project was we wanted to introduce a lift, but because the shaft, which was originally meant for ventilation, is not vertical, putting in a lift shaft, which is normally all the mechanism is vertical, was quite a challenge. So the use of scanned information versus 3D modeling and integration with various disciplines helped with clash detection, and we managed to resolve this problem. So it was not easy. We had one chance to get it right, and we managed to do it after a lot of background challenges. But when we actually did it, we managed to resolve the problem. So this is kind of some of the benefits of using digital. And what I'm also doing, kind of taking it to the next level, if we go to the next slide. As Ron has said previously, what I'm also kind of pushing forward is to use digital technology for conservation, so which is also known as Heritage BIM or HBIM. So it's kind of trying to say that it's not just what we have physically that we see as a model, as a geometry, but we want to add on another layer of information to understand what's in the geometry. So in traditional conservation project, you get a 2D information, and then we get an O&M manual, but what I'm driving is I want that information to be translated onto a 3D object, which could then fit into our database and eventually create this digital twin where we'll be able to manage the asset in a more collaborative way. So if you go to the next slide, Tron. So this gives an idea of what is a 3D object, which is just an object. So using the traditional method where a CAD drawing is usually done for any building works, and incorporating that CAD information onto the model and adding data to the elements that has been kind of this orange elements are part of the building that was repaired, so that sections of stone was newly fitted in. So this was a pilot project that I have been championing, and we managed to show that we can get information for building conservation works into 3D. So it is quite a challenge, but it's proven to show that it can work. So we are still in the teething process, but eventually the hope is to go on to creating this future where we are talking about. And it does come with challenges, as we know, because the geometry for heritage buildings are quite complex. And as I mentioned, very often they are not vertical, not horizontal, but there is kind of understanding what is reality versus what is in the model. So there is also a challenge understanding whether the model you just get from a 3D model, whether it's reliable. But of course, it then comes to a question of what are you using the model for? If you're going to visit and just understand the geometry and get a feel of that space is fine. But if you're going to use it for management and creating a digital twin, then you need to go on to the next layer to understand what's beneath the skin of what you see on the surface. So at the moment, there are various challenges we are facing. Of course, there is the cost that's involved, versus quality and time. And there is a knowledge gap between people who knows technology versus people who know conservation. So in some ways, I'm trying to bridge that gap. And again, like Vince has mentioned about interoperability between different systems. At the moment, in some ways, how a model is done versus how the facility management system works, they don't quite talk to each other. So these are among the challenges. Hopefully, in the future, we'll be able to resolve. Anything else?
No, thanks for now. I'm going to stop sharing, and we're going to go over to Federico. So thanks very much, Catherine. Federico, with your group's work on such a project as Mesh Lab, the Nexus format for 3D heritage repositories, and RTI viewing, would you say a little bit about the challenges of working with different formats, including trade-offs between levels of detail and speed of delivery to popular platforms such as mobile devices?
Yes, most of my work in research has been involved with efficiently delivering assets and 3D assets to the user, especially the web. And there are, to explain what's behind, I want to make a parallel with the 2D world and see how those technology translates. What make a big difference in delivering assets? The biggest one was JPEG, the invention of image compression. And you can see that cutting the size of the images by 10 makes our world much richer in size and quality of whatever video code whatever image we are going to see. And the same things applies also for video. So we started with MPEG and we arrived to H264 or something like that. So technology that allows us to have a very rich 2D world at our disposal. And the main reason is compression, because otherwise we will still be using GIFs or something like that. If GIF was a compressed format, by the way, and also that make the first animation that we were able to experience because it was compressed. Otherwise, the data is. The point is, do we have something similar happening in 3D? Well, the problem is that the 3D content is much more complex and less standardized in its development, that compression has always been lagging behind. The main problem is that there are a lot of compression algorithms, but none of them is if save from some a very few exceptions, they are slow because the data is much more complex. And so one of the big challenges is getting efficient, fast, powerful compressions for 3D formats. The first effort that were somewhat successful were in 2016, 17, I think, together with the binary distribution of data, GLTF, where the data started being distributed binary. There was a flurry of algorithms, and Draco from Google is successful because it is fast, mainly. Is able to get a decent compression. The compression is not much more than smart quantization. We are on the type of compression similar to when we have images in 256 colors. The old guys of us remember, and it's something like that. So you are throwing away some data in a smart way. There is nothing so complex like JPEG Fourier transform like processing, but it's efficient and it's fast, and it makes a huge difference because it makes usable. It became possible also because JavaScript has become fast enough to be used. But this is one of the technologies that makes possible to have a rich world in 3D because it grows 10 times the amount of content it can deliver efficiently. But there is still a lot of work to be done on this. This is not exactly a standard; it's more of a product from one company. But it's a promising research work line. Keeping in mind that speed is the key of this stuff because bandwidth is getting faster, and if you're not quick enough to decompress the model, it's not worth it. The trade-off between spending the time to decompress and getting less data from the network.
Could you? Sorry, finish thought.
Yes. No, I was going on another topic. So.
Yeah, well, just on the point of compression, I think you've said elsewhere about there's compression on the front end, the model, but then the devices have to be suitable for decompressing, and there hasn't always been enough work on that side. Can you say more about that?
Yes, no, I'm saying that the crucial point is that most of the scientific work has been focused on compression rate. So to squeeze every bit of the data that you can, and very little on speed. It's a different game. And especially, well, the important part is especially the compression. This is true for pre-created content. Stuff that is being scanned, comes from photogrammetry or has been modeled by hand. There is a whole another topic, which is delivering content that comes from 3D camera, so content on the fly. Exactly like you have video that has been optimized on your movie at home and streaming video on the web like we are doing it right now, where the data is recorded by the camera, compressed on the fly, and then decompressed on the fly on the other end. And this part is totally unsolved, at least for now. So being able to compress efficiently 3D data in real time is an open problem. It's very important that you also make a big difference in how you can include augmented reality and data that includes sensor data that need to be processed and then delivered to the user on the other side of the cable. And this one is another point that is very important. And it requires not only standardization, but also development.
Right.
It's not a problem of...
Finish that. Sorry, finish your thoughts, please.
Yes, I'm finished. And on the other hand, there is another couple of technologies that in 2D are pretty easy to do in 2 dimensions, which is how to deal with very large images, like high resolution images, but also maps, for example. And the technology in 2D has been standardized, by the way, also by IEEE, which is a pyramid of tile where the image is cut into small pieces at various resolution, and you have a very simple algorithm to create them and to represent them on the viewer. And this is a game changer because viewing a very large map that you can interactively move around whenever you want, and you don't need to download the entire map before being able to view it. And this is allows products like Google Maps, for example. Without it, we wouldn't have Google Maps. So you understand how influential this algorithm was in terms of how you deal with very large data. What about the 3D content? How to move this kind of feature in 3D? Well, this is a very difficult topic because while in 2D, you exactly know which part of the model you need because the perspective is easy, the model is flat, the distribution of the model is regular. In 3D, everything is complicated. And this has been lagging behind for a long time. We are seeing some application of this in the technology that were mentioned by Mark before, which is cesium and nanite in the Unreal Engine. These are serious attempts to implement a similar technology, which is being able to stream the content, to make the content adaptive to the viewer, and to being able to make use of the data set, adding a limited part of it. Cesium more on the delivering content aspect, while Unreal is more on the rendering part, because also even if you have your model in your PC, it may be too big to be rendered. So they are covering two different aspects of the problem, but they are approaching a solution for a very important problem, which is scalability. The ability to adapt the capability of the renderer to the viewer capabilities, and the amount of data that you're able to fetch from the network, and be able to work with limited subset of the data set and still be able to present something to the user. This changed a lot the kind of experience. You don't want long loading times like in games where before switching to the next level, you need another, you have to download everything and stuff like that. So this is more of quality of life implementation, but quality of life, if you're going to spend hours in this world, it's pretty important. And you can get some inspiration on what has been done looking at the games, because many games have this problem, huge content. It might be online viewing things, a simple thing like Minecraft, for example, where you have a shared world and you need to deliver the pieces to the user. So there have been many different solutions attempted and with various limitations, but that's a good inspiration of what is going to come in terms of possibilities.
Great, that's a great point, I think, and appreciate that. We'll come back to any of those questions. Let's segue over to Karina. I see you're on the call. Karina, are you there?
Yes, I'm here. Can you hear me?
Yes, great. So can you say a little bit, with your ongoing research in mind, would you share some ideas about the few national initiatives for shared 3D content repositories? And given the planning for long-term sustainable, persistent, and fair compliant data sets, and maybe you can say more what fair means here. Could you say a little bit about that, please?
Yes, Ronald, thank you. So I mean, maybe it's worth mentioning that we are seeing some interesting developments from different national funding bodies. So, for instance, in the UK, as I understand, in France and in Germany, as well as the European level, governments are setting repositories of 3D content that will allow to serve as gateways or aggregators of different content which is being produced. So myself, I was leading the scoping exercise for repositories for 3D content that will potentially be used as a gateway for content from cultural heritage organizations and other researchers that generate 3D models in the research. Now, this is interesting in the sense of having a portal or a gateway in which you can access 3D content that be put together in the ways that were being illustrated before in the example before, right? So there are a few challenges around there, indeed, about allowing content to be findable, accessible, interoperable, and reusable. But I think there is a lot of appetite to understand how 3D content, which is now being generated through many different projects and many different initiatives and communities, citizen science, all of these projects can be used, reused, and potentially find ways into ideas of the metaverse or metaverses, right? So I suspect that in the next 5 to 10 years, we'll see a lot of this infrastructure being set up. And I think it's interesting to kind of coordinate and collaborate at an international level to understand, how we can even make all of these infrastructures interoperable themselves so that users can potentially benefit. Now, with regards to other areas that might be of interest is to understand, for instance, the models for sustainability of these infrastructures, the assets themselves, but also for the commercialization of assets. So I know there is a lot of interest from cultural organizations, whether with this type of technologies and infrastructures, there is a potential for commercialized 3D content or parts of their business or their processes, right? So this is a kind of unexplored area that once these technologies are a bit more mature, might be interest to look at. So, I mean, some examples maybe that this infrastructure will contain is, as I suspect across the world, museums are doing 3D digitization of their collections, right? That's a typical example in which an organization, as I suspect, many businesses which are undertaking a digital transformation are generating 3D assets, right? So this is a typical example in which you have an organization that has 3D content. It can be dozens, but it can be hundreds. Eventually, it might be thousands. And you want to allow for this content to be put in an infrastructure where the content is easy to manage. The data can be managed, but also you can support the preservation of the 3D models themselves. And allow for access with all of these standards we have been discussing. So this can be a use case, and other ones, I guess, the ones that were mentioned before, this idea of digital twins, right? So there is a lot of digitization with regards to buildings, but also more synthetic reconstructions, for instance, where archaeologists attempt to do reconstructions of a hypothesis of how a place will have looked like, right? This is not a digital twin as such. Is more a synthetic, hypothesis of building. So these are examples that we see that are being generated. And as I said, it will be interesting to look at the developments in that area to see how much content we will be able to aggregate and create new environments with this content.
Yeah, and the project you led here in the UK, funded by Arts and Humanities Research Council, was in some ways dovetailing with an attempt toward a national collection. The idea of trying to interconnect collections across the country, including smaller groups. I don't know if you can say a little bit about that sort of challenge of how to be more inclusive, and it's not just the big collections or go ahead.
Yeah, that's right. I think when we were looking at it, we recognized there is a need to level up the field, right? In a sense, because not even about accessing the infrastructure, but even accessing the technologies to generate the 3D assets. You're right that probably the larger organizations, just like with industry, right, they have the resources to be able to create and curate and manage and create digital access to this content, but it is indeed the medium and the smaller organizations which sometimes need support for the creation of assets or accessing that expertise and knowledge. And this is indeed where we want to have an impact, right? That we are supporting across the field all organizations in this case, supported by the Arts and Humanities Research Council that might wish to have, to explore that type of content and provide access to that content in an access infrastructure.
No, thanks very much. In essence of time, I'm going to just show a few more slides and then we'll open up whatever time we have, and don't want to keep the next group. So let me, can you see that okay? Yeah, thanks. Good. So Federico, we introduced you, and Karina. Thank you for your contributions as well. I just wanted to say a little bit about some of you will have read the material about this International Image Interoperability Framework. And I should apologize in advance, yet another combination of similar letters. So here with the IEEE talking about IIIF, and interoperability is the middle name. This is a group that's been going for about 10 years, and it is largely now the de facto way of handling digital library collections, and not just as silos, but the interoperability is an important part. And one of the early puzzle pieces, some of us were talking earlier, is medieval manuscripts that have been torn apart, cut apart, but are physically separated. And so this was one of the ways for collections from Library of Congress, British Library, Bibliothèque Nationale in France, Vatican Library, collections scattered around the world. So this was one of the ways to put them back together digitally and actually match up the cut out illuminated letter, etc. We have a similar challenge in the 3D world for pieces of pottery and statues that are scattered and are not physically together. So that's an interesting part of it. But the standard has grown from initially 2D to also audio and video material for sound archives and so forth. Again, because of time, I'll keep going and hopefully be interested in reading more. There are two 3D groups. There's a community group that's been going for more than 5 years, and that has lots of people who've come and are part of the discussion ongoing. It's where many of us here met, and then a number of us were involved in forming a technical specification group, much younger, in the last year or so. And the goal is to put together interoperable APIs that are not specific to any one format, but will help enable the interchange and the creation of what you might call digital dioramas or mini metaverses with a variety of formats. These are the various groups that are involved with the technical spec group initially. It's an open door, happy to have more people involved. And we have some collaborations with a number of known people, including today and hopefully for the future with the IEEE Standards Association. So thanks again for that. It would be an obvious point, and we really should reach out to you, Mark, and and Hugh, and get involved with the Metaverse Standards Forum, which our intention to cross over and interconnect there as well. This is a very rough sort of view we're working on, and shameless plug, we have lots of people who are specialists, lots of content to deal with, lots of puzzle cases, and we're looking around engaging funding bodies to try to handle the technical workshops and gathering people together for some of the work. There are 6 core user stories or use case scenarios, and this is just listing them briefly, and we have a GitHub repository to keep track of those and how we're going and getting involved. Some of them will be obvious, and some of them are just to be very clear, based on a lot of research in user stories from a variety of forms, and always looking for more input if something is missing. So anyone in this call and in the future, please get involved with that. Some of the repositories, MorphoSource in particular, can handle CT scans, which is important from any of the biological and medical areas, as well as archaeological and art history, among others, musical instruments, etc. It is complicated. This was a very helpful guide that's been added to, and it's good we have the people from Unreal here, Mark from Epic Games and the Unreal group. But you see, there's left-handedness and right-handedness, up and down is different. And that's crucial for how we're going to put things together from different orientations, coordinate systems, scaling. And just for fun, Google, in some of their models, among a few others, put things in polar coordinates rather than Cartesian rectilinear. So translation is part of it. Thankfully, we have enough people who love geometries, so that's a good thing. And a couple of factors of interoperability are there, I think, to puzzle, including persistent IDs. Some people will only care about the composite, building, body, etc. But others art historians, anatomists, architects will be interested in all the pieces, and all of those have to be uniquely identified and trackable. And that's going to be an interesting point. It may not be an immediate challenge for what some think of the metaverse, but it will be for the kind of cultural heritage and some of the research areas. And finally, there's some references there for some of the various works in which we're involved. And I will stop there.
Thank you so much.
Thanks.
Thank you so much, Ronald, and all your distinguished panelists. So we are now at the last agenda item, which is the panel XV, Extended Meta Universe. So we will have Steve Mann as our moderator, who is recognized as the father of wearable computing. We have myself and Tom Furness, who is recognized as the grandfather of virtual reality, and Joseph Paradiso, who is Alexander Dreyfus Professor and also Associate Academic Head of Program in Media Arts and Sciences at MIT Media Lab. And lastly, Tom Coughlin, our 2023 IEEE President-elect and 2024 IEEE President. So, Steve, I will leave it to you to lead us for this panel.
Excellent. So, can you all hear me?
Yes.
Okay. And so my technical team was not able to get WebEx to work with any of the computers I have in my lab. So I've cobbled together a piece of hardware that air gaps my computer. So I don't know. Tell me if you can see my screen okay.
Yes, we can see your screen.
Okay. So I want to talk about the extensions to the metaverse. I guess I'll just go F11 here and go full screen. And you, Yuan, and I have been working on this for some years now. I guess just generalization. And XV is the extendiverse or extended metaverse, extended meta universe. There's all these verses like holoverse, omniverse, and metaverse, and extended universe, extended multiverse, and so on. So we're kind of putting them all under XV, where X is this variable that represents all of them. And firstly, just a little bit about myself, I guess. I've been living for 48 years since childhood in the 1970s in this sort of computer-generated world on top of reality, what we call XR, extended reality. And it comes, if you look at you've got physical reality and virtual reality, and since my screen share is not working, I might as well just show it in real life. P is the physical reality and V is the virtual reality. And we can think of them on a pair of axes, kind of like, say bits and atoms, alpha atoms, beta bits. And, physical is out here on the reality axis and virtuality axis. And we've got, sort of see this here. And then now we have augmented reality comes along. And, I've got the Meta 2 eyeglass here. For example, that's an example of an augmented reality eyeglass. And the Meta Pro over there is another example of an augmented reality eyeglass. And so that has some bits and some atoms to it. There's a kind of combination of bits and atoms. This is the Meta 1, the original Meta. And this augmented reality, now we can flesh out that space. And if you can see, it divides into octants. I mean, there's sort of 4 logical octants. You can see it, quadrants. I mean, it divides into these 4 quadrants, the space. And so we've got something here, we've got something here, we've got something here, and there's something missing from here when you look at it in this bits atoms taxonomy. And the thing that's missing is, we'll call that diminished reality. Technologies that deliberately diminish reality. Technologies like sunglasses and baseball caps and earplugs and things like that deliberately cut down reality, DR. And the quintessential example of DR is the float tank, the isolation tank. So this is the 4 quadrants here. Ice water swimming is, one example. And so this is a float tank VR. Now we can, if we go inside a float tank with a VR headset, you can kind of get this idea here that we're in this reality that's modulated or you only have virtually, you cut out all the external input. And so now we've got these 4 quadrants. And what we said with XR is let's extend beyond these. Let's extend human perception beyond these, but also let X be a general variable that can represent all 4 of these. And so we got, all 4 of these different realities here. And what I can do is I can just get rid of them all and have only one of them. And I don't have to, it simplifies life because I just have this one thing. And so, moreover, X means extension beyond what the realities are. Here we have ice water swimming as a quintessential example of reality. And we've got the VR float tank as a quintessential example of virtuality. But now we can try to go past 100% and increase our perception. And I want to talk more about that later because we're kind of talking mainly about physics and math here. So my own work since childhood, one of my childhood hobbies was photographing and seeing and making visible electromagnetic radio waves, seeing metavision, which is the vision of vision, sensing sensors and sensing their capacity to sense cameras, that sort of thing. And so many of these things here are extensions, trying to see more beyond what the human can see in the infrared, see in the ultraviolet. I'm seeing radar waves here. This is an example of seeing actually the radar wave from seeing Internet of Things, hand wash faucets. We can see them now as they see, and sensing automobiles, of practical use, self-driving cars. We can look at and visualize, see and photograph the sensory capacity of the car to know that it's in good working order. And this is a drone swarm, swimming it out and various things like that. These are all extended realities. And this is a motor with a row of 100 green LEDs attached to it so that it traces out its magnetic field inside the motor. And then there's RGB here. And so these are examples of extended reality. This is my bicycle, and I've got a bunch of LEDs on there that show the powertrain trinography, the internal motor magnetic fields and their effects on the powertrain. And so these are all examples of extended reality. There's 2 microphones and their capacity to listen. And of course, we can see the interference pattern that this capacity to listen has. We can see it, we can photograph it. And so that's an example of XR. And there's a simple definition of XR, which you can look up online. I want to move right along to XV though, because collaborative or shared XR is what Yuan and I are talking about and calling XV, the Extendiverse. And this is my office at Meta, and this is an example of collaboration in XR. And so we provided a definition of XV, which you can look up. And broadly speaking, it's shared XR intelligent environment. And then we come up with this definition. And so one way to think about it is to think about it in terms of spatialization. Like you've got these realities. The metaverse is kind of a shared virtual reality. It's coming out of the page, if you will. Bits and atoms are here, reality and virtuality, and then the metaverse comes out of the page. And the Extendiverse is a shared XR. XR goes beyond, and then XV is the shared, where this third axis here coming out of the page is sociality. It's kind of the social or gamma is the Greek letter we use, genes, small unit of humanness. And so that's our third axis. And so we can take that as the Extendiverse as this extra axis. And it gives us grand challenges. 5 of these grand challenges I'm listing right now. We've identified 5 challenges. One is standards. There needs to be standards like, how come I can't use WebEx? Well, it's not a standard, whereas Jitsi is standards-based. We need the same thing for the metaverse. We don't want the metaverse looking like WebEx. We want it looking like Jitsi. So how can we make standards? How can we build standards so that everything's standards-based? RTMP, RTSP is the standards for video conferencing. There's standards for JPEG. There's standards for 2-dimensional stuff. How do we make standards for the Extendiverse? And so as we go down this list, I want Yuan to speak to standards. I've kind of mapped out this little thing here, standards. And then the second challenge is human factors and perception. This taxonomy is only addressing the physics of the situation, not addressing the perception. And perception is another element that wraps around all of these. And I want kind of Tom Furness to speak to perception and human factors. And then reliability Joe, we brought in Joe because he's kind of a boots on the ground. He builds things, understands things. And so how do we make this thing reliable? How do we make this technology actually work? Why is it that every time we have a video conferencing, we have a series of technical glitches? They're only going to get worse when we bring it into 3D. How can we make it better and not worse? As the IEEE slogan is, advancing technology for humanity. And I want Thomas to speak to the storage issues. Like surveillance is lifelong capture of your whole life. I've been kind of doing lifelong capture of all kinds of things like respiration, heart, ECG, what's inside my head, what's around me as I go through my day-to-day life. So I'll just briefly touch on this fifth one, ethics, and then I'd like each of the other panelists, to talk about these four things. So if we take that model, alpha, beta, gamma, bits, atoms, genes, and we take 1 over each of those, or if we take S of the scale of those, just the scale, let's look at the scale of this. Instead of the amount of reality and the amount of virtuality and the amount of sociality, let's look at the scale of physicality and the scale of virtuality and the scale of sociality. At the very small scales, we've got sort of atoms, and then you've got wearables, and then you've got under wearables, and then you've got outerwear, and then you've got bicycles, and then you've got cars and streets, buildings and streets, and then you've got cities, and then you've got provinces or states, and then you've got countries, and finally you've got the whole world and the whole universe. And we can say that there's a clear demarcation between technologies that are part of us and technologies that are around us. And so let's say that we have technologies that are part of us, we call that the environment, and technologies that are around us, we call that the environment. Likewise, on the social axis, you've got individual, and then you get teams and groups and larger organizations. So you've got, and if you look at this in terms of a taxonomy, if we reverse these and take 1 over the scale, we've got body. How wearable is the technology? When it's really far, the stuff at the edge of the universe goes to the origin, infinity maps to 0, and we've got 1 over S of alpha atoms. That's body, and then we've got control as 1 over S of theta, and 1 over S of gamma is ownership. So BOC, body, ownership, and control are the axes. And I want to think about this as a taxonomy for these XV technologies, because we can say this is just a little model here. That has the body along this axis, a control, whether you control it or someone else controls it, and ownership, you own it, does somebody else own it? And ordinarily, technologies, if I walk down the street, normally choose what I wear, I choose my own clothing, but I don't choose the building. But that bank over there, I don't own it, I don't control it, I got no say over it, but I can choose my own clothes, I can choose my own smart eyeglasses and my own VR headset. And I choose what I wear, and I own what I wear, but I don't. Now, the counterexamples to that are technologies like handcuffs, which are wearable. They're of the body, but you might not control them. You're not in control. So these are the off-axis. And so when we build technologies for humanity and the ethical considerations, this taxonomy, BOC taxonomy, will help us understand that. So just as an example, there's a famous joke, beam up my clothes, Scotty, that wasn't very funny. That's a very deeply philosophical thing, because it helps us understand whether it's part of us or part of the environment. We expect our clothes to go with us in space-time travel and science fiction. Or the car analogy or the boat analogy. 2 boats collide in the marina, and one of the captains yells, "Hey, you hit me." And it's not like your boat hit my boat or your car hit my car. It's like you hit me. We think of that as part of ourselves. So that's environment versus environment. And this is a really good example of that clear demarcation here, that, you have the inside and the outside and the environment versus the environment. And so, and we like to think of the environment as part, the boundary between these two as part of the environment, part of us. Clothing we think of as part of us, not part of the environment. So this diagram here, this map, captures that essence. And that's really where the ethical grounding is. So as far as the other 4 grand challenges are, could you speak to standards for XV and your take on XV? Could you give us a kind of please give us kind of fill the group in on the stuff that you and I have been working on for many years now.
Yeah, of course. So thank you so much for the wonderful introduction. So let me speak about standards. So first off, I think, like Steve pointed out, today we had several technical issues, and those could we should do something to prevent such kind of things happening in the future metaverse, which is exactly a trend that I have been observing in the recent years. So previously, we kept talking about the so-called market-driven standards, which means typically we started standards development after the technologies and products were mature enough. So people will say, okay, there are some like conflicting products or services in the market. We need to do something to harmonize them. That's how they figure out they need to develop standards. But in the recent years, in more and more cases, people will feel that standards need to be involved earlier than later. The earlier, the better. So we start keeping standards in mind from the very beginning, and standards could even be developed before the technologies and the markets are become mature. So we call that market-driving standards, which means standards can play a leading role in the industry, in some, especially in the emerging technology areas, so such as the metaverse. So I would expect that of course, metaverse is a super cross-disciplinary topic. It's a super cross-industry area. So if we do not keep standards in mind or start developing standards, designing the framework, the overarching framework of standards from the very beginning, we will be having lots of, I would say, waste in terms of the efforts and the time and the money we put in the industry. So that's exactly why I have been working with other people like our panelists today and our IEEE people to try to use standardization as I would say a tool to help pave the road.
Wow, I love that. That is so fantastic. That is great. I like the way you've got market driven versus market driving. Like if we just zoom in on N versus ing, it's just so succinct and wonderful.
Thank you. I'll stop here and leave you to it.
Beautiful. So Tom, can you tell us a little bit about some of the human factors and how they wrap around these three axes, alpha, beta, gamma, the reality, virtuality, and sociality, or S of alpha, S of beta, and S of gamma, or 1 over S of those three?
Actually, thank you, Steve. In fact, it's an interesting discussion we had the other day, because I was thinking of this as strictly as like a mathematical formalism. But I think the useful point on all three of these axes, bits, atoms, and social, that the 0 point is the individual. And so in all cases, you're going from what is identified for you in physical reality to the outside, going on that axis, to what is your bits, if you will, or where you are, versus information that relates to what is outside. And then the other one is you as an individual versus you versus your interaction with others. So I thought that was a really interesting insight of that. It changed the way I looked at the analogy you've made here. So I thought that was very insightful.
Oh, that's cool. Yeah. So it's sort of the individual, like if we think of the individual person as this core.
It's the origin point.
It's the origin. Yeah, that's kind of one way of thinking of it. Is that we are at the origin of our own world, and then these axes extend outwards. Like it's this first person perspective. Mm-hmm. Kind of makes sense. It's like you're inside my head looking out at the world or something like that.
Yeah, I thought it gave an interesting view of the thing, because the thing that we all presumably know is ourselves, or at least we want to understand ourselves. So we're, and everything else has an impact upon us. Of course, inside of us, there's impacts, but there's things that come from outside, and they can be represented, by the physical world and its impact on us, the world of data, the world of information, and its impact on us, and then the world of other people, and all those things, in fact. And I think this is where this model kind of gets interesting, is that, it's basically, if you deal with this as I can draw vectors within these three axes, is that presumably you could say, if I have this space, what is the interaction of all these three things on myself, or on people like me who might be other origins? In other words, we're each of us, in a sense, has our own origins. We each would have these three axes around us, and then we're interacting, between these things, and that's kind of like these vector relationships. So, at least it's some, it's all analogies. How far it goes, I don't know, but it's an interesting way of thinking about it, I think.
I really like the way you think about that. Like, certainly know thyself is one thing.
Indeed.
And also the notion of roving vectors, of roving, like we have these vectors that intersect with one another. And in some ways we can think of each of us as a set of, as an origin point that's moving through space.
There was another thing it brought up, since we're using a bunch of meta terms, right? Metaphysics. And I say that in a sense as a play on words, right? Because metaphysics is a branch of philosophy. It deals with first principles, abstract concepts, being, knowing, substance, cause, identity, time, and space. I'm reading that off a definition, right? And I'm just thinking about, ideally, and this is why I think human beings create technology for the most part, is we're driven by a need to understand ourselves in the outside world. And certainly that's true of people who are engineers and scientists and stuff. And the thing about this XV approach, I think, is it may give us ways to make to actually substantiate things which might otherwise be abstract concepts, and maybe find new ways of understanding ourselves and the world around us. Whether it be on the social level, be on the reality, or on the data level. And examples of that I think of directly, for instance, if I'm doing modeling of something and I'm using some virtual reality to try to understand the model, or visualize, say, organic molecules by looking around them and essentially rotating them and playing with them. Things like that we might be able to do that create new ways for us to understand the world around us. And potentially, even if you can then actuate those things, maybe connect that up to simulations and or actually construction of stuff, and being able to make new ways, new things that never existed before, or new ways in which we can communicate, or and essentially, can we substantiate things that sometimes have been seen as being more metaphysical and make them something that is closer to us being able to communicate better?
Wow, that's really well put. I'm sort of the word metaphysics is kind of overused or soft used. It might soften our argument because I'm thinking the physics of physics, if I think literally what it means.
Yeah, you'd like to get self-referential stuff, and I think that is very interesting. And of course, that's the whole thing about I think, therefore I am, right? Since I can refer to myself, I exist, right? So.
Yeah, self-referential, and so now to put another spin on this, Joe, you do a lot of stuff with wearables. You've dabbled, you've played a lot in the wearables universe. The thing, one of the big issues with all of this technology is getting it to be reliable, where reliability is important. Like automobiles, if they were built like computers, imagine, to put on the brakes, you'd have to select the braking menu. You'd have one control wheel that controls the brakes and the steering and everything else, and the volume on the radio, and you select that menu and roll it over to this. So we've software is garbage for the most part. And because software is garbage, and because our world is driven by software, we've gotten used to garbage. Like when I grew up, I was used to things like this cathode ray oscillograph that works reliably, like it's 100% reliable. It's still working after 80 years. And my Apple II computer over here from 1978 still boots instantly. And so I grew up in an era when things worked. And I'm really frustrated now in the era that doesn't work. And I almost want to start a little Amish community that lives in the 1970s because I really can't stand garbage or crap applications and stuff like that. And things just don't work anymore. And we're starting to see that in automobiles, that people are getting used to the idea that things don't work. People are getting used to unreliability as the norm because they've grown up in the smartphone era where smartphones are full of crap applications. So how, Joe, if you could maybe speak to the importance, like how do we build technologies, the Extendiverse, how do we make XV reliable and like how do we make it work? What are the technical challenges really for XV? The hardware, glasses, how do you make these glasses physically work? And you know how to build things and you've done a lot of making. Maybe you could give us a little riff on that.
Sure, Steve. I wasn't